Hello friends, last topic of the fifth unit. Now we are going to see in this video. It is remote sensing and GIS. I try to give an introduction part of remote sensing and GIS in this video, right? Introduction to remote sensing. Remote sensing. The two words sensing. We know our sense organs, eye, nose, skin, all have their own sensing ability. Here the remote, it is not a TV remote, but we can take it as an example. The TV remote, how we switch on the TV or switch off the TV or changing the channel, whether any wire is there, some sensors moving, hitting the television and give the command, and the TV is get operating, right? Similarly, here our best remote sensing is our eye. It is seeing all the object with distinct nature. Each object have different colors. The eyes have the ability to detect it, right? And it has the world highest megapixel resolution in the world is the human eye, right? It can see very detailed color distinctness, but it has memory capacity, but the retrieval process get very, maybe some person have high ability, some person have low ability, but all are having the equal potential. Same thing, same concept is adopted in remote sensing. Instead of eye, the camera sensor is sent to the space. It revolves around the earth. It captures the image and send back to the ground station. We have to process it to get the information, right? That is the remote sensing. Teledetection, earth observation. Remote sensing is more than looking at pictures. It is a different way of looking consciously at a earth surface object with prior knowledge. So remote sensing is observing with artificial eyes. The artificial eye is sensor. So remote sensing is the science or the techniques of the deriving information about the earth's land and water areas from images in point feature or line feature at a distance. It relies upon measurement of electromagnetic energy reflected or emitted from the object of the interest at the surface of the earth. So one is looking at the physical nature of spatially distributed features without touching them, without any contact with them. That is the right word. Without any contact, we are collecting the information. That is remote sensing. So remote sensing as source of information gathering. Traditionally, visual characteristic, field equipment, manual recording, field work, that is surveying, major portion is based on this. Remote sensing based on the electromagnetic radiation characteristic, direction from a distance, analog or digital recording, non-destructive, there won't any touch or anything, incidental field sampling. So comparison with the eye and remote sensing is the same. It is organic, subjective, choice of the object on the spot, individual point, local interpretation. Instrumental, objective, choice sensor parameters in the advanced object analysis, afterwards on complete image. The instrument keep on clicking the images, storing it, whether the interest is not there about the particular spot or not, it will keep on. But the eye, where we look, it sense. That is the difference. Here the instrument, where it rotates over the globe, it records. That is the difference, but both are same. It has own subjective knowledge. It sends back to the ground, we have to process it. Here the eye sends to the brain, we decides, right? So the properties, it gives the overview of the region, differences and coherence of the particular region. It has a flexibility of a variety of sensors are available, techniques are available, image processing algorithms are available, so that we can produce many data outputs, reproducible and analysis. With single data we can reproduce many things many number of data. Actuality, in addition to the conventional mapping, specific data for application can be added. Up to date information, current data we can update. Interactivity, cooperation of human knowledge and the machine operation, both the thing is possible. And it is dynamic also, capability of monitoring with time series of data at particular date, particular time we can collect the data, how the change happens, past and current we can check, reveals the changes, that is a change detection is possible. Moreover, the invisible becomes visible. Many forest areas couldn't be explored by the human being. The satellite image will explore it, we can get the data. Even number of animals we can count or we can track based on the remote sensing data. So extrapolation of point measurement, with the available data we can extrapolate also. Open up an inaccessible region, integration with GIS. The remote sensing data can be integrated with the GIS, geography information system, such that both the thing give the proper map or proper analysis data, right? So complementary use of passive and active sensor is possible. Reflective and emissive part of the electromagnetic spectrum is the core one we use in the remote sensing. So application, meteorological application, in daily news they are telling about the weather forecast, climate study, global changes, they are informed. It is based on the remote sensing data. Hydrology, water balance, energy balance, agrohydrology, everything we can study. Soil science, land evaluation, soil mapping is possible. Biology or nature conservation, vegetation mapping, how vegetation get increases or decreases, that mapping, monitoring can be done. Vegetation condition assessment can be done. How much yield can be produced by a particular acre of land, we can closely watch and we can give the data. Forest inventarization mapping or deforestation, how it happens, we can check. Forest fire detection, everything is possible. Environmental studies, source or effect pollution, groundwater quality, climate change, everything we can study. Agriculture engineering, land use development, erosion assessment, water management. Physical planning scenario studies is how the land can be utilized. Land surveying, topography, spatial data models, yes, these are the various areas of application where the remote sensing plays a major role. So there are n number of variety of satellites. It is rotating. The large circle denotes the geostationary satellites, that is, it is from the outer surface of the earth, the distance is 35,900 kilometers or approximately 36,000 kilometers. These satellites are called the communication satellites. These gives the weather data. Our satellite TVs, which gives, we are seeing all the different channels, it's based on these communication satellites. This orbit is the sun synchronous orbit or polar orbiting satellites. These satellites gives the nearly, it is from 750 to 900 or 1000, 750 to 1000 kilometer range height. In that height, these satellites will rotate the earth in the polar direction. It is in the geosynchronous direction, right? It is in the equatorial direction, it is in the polar direction, right? So the images can be obtained, the visible spectrum, that is RGB spectrum. This is infrared spectrum, the same area, how the infrared image look like, water vapor, how it look like, everything we can get through remote sensing. One of the sample images you can see here, how the variation or change you can see in various combination of bands, right? How the land gets splitted, how the river network we can detect based on the various bands. Thermal mapping based on thermal image. This is the different. This is one of the thermal band, but the band is 453. Here another is it is 247, the band combination. and monitoring urban trends, how the urban area get increased or decreased, right? We can monitor it. It is a Mount Fuji, one of the China mountain, how it's look like. You can see pollution in Eastern Europe. You can, the red indicates the spread of the pollutions. Colorado from IR, this is our Indian remote sensing satellite image. It is spot French satellite image. Irrigation field 50 kilometers southeast, how it, this is the point. We can, based on the type of resolution, we can explore a lot. See, this is the field of agriculture, how the variation of crops, you can see it. Deep positional landscape, the English fence, estuarine, creek channels, how they move, how the tributaries, everything can be. This is a black and white panchromatic image. This is a Landsat image in 84. It was taken for Appledore. Another sample images. All these are, I can speak about large, but I try to show. Before speaking about the image, we should learn many things, so I am skipping those things. See how clear about the resolution. One biggest campus with, even you can see the cars, right, in the parking areas very clearly. Shadows of that, trees, everything can be seen very clearly. This is the one of the, this is a pyramid, famous monuments, you know how it look like through the satellite image. It's a agriculture land, nearby there is one factory like location, how the crop variation happened. See, this is the changeover, what happened to the particular area's crop, whether it get affected by any disease or what happened. Such changes can be noted down. So what we mean with remote sensing? The remote sensing data and information, how it happens: recording technique and image construction. The sensor record the image by pixel, it stores remote sensing data. Based on the particular pixel resolution, the clarity of the image depends. Before the sensor, aeroplane fly, it collects, but the height variation is different. So based on that collected data, the data get pre-processed, data analysis can be done, the report can be generated. The report can be generated based on the involvement of the Geographic Information System, that is GIS. Right? There are various processing methods are available. Based on the requirement, the processing method choose, and the data get analyzed, and the Geographic Information System also will support the data analysis, and the reports get produced and it sent back to the user who requires. And the remote sensing data totally depends upon the electromagnetic energy, the incoming, that is incoming from the sun or the energy source, and how much get reflected back. Based on that albedo, we get the image details. This is the major graph and the detailed graph, how the different soil or vegetation or water, how they reflect back, how much percentage of energy it reflects. See, the water maximum it is of not even 5% only get reflect. Remaining thing, the water absorbs the electromagnetic energy. So whatever the satellite imagery you see, the water bodies look like black or the dark blue. And vegetation, how it reflects in the green visible range, it is very limited, but in the infrared range or near infrared or mid infrared or thermal infrared, the vegetation reflecting is different. We can study in that area. If it is wetted soil, it has a low reflection compared to the dry soil. right? So based on these reflectance percentage, we can get or infer the type of object, right? This is the basic concept used in the remote sensing. And the geographic information, it can club different layers of data into single platform, and it can analyze and produce a report. So collecting, storing, retrieving, analyzing, and producing the map, that is the overall process involved in the GIS, right? So remote sensing is collection of data, collection of imaginary. Gis is a platform we can make different layers and produce different output. This is the overview of the remote sensing and GIS. See, the background is the traditional map. The satellite image can be superimposed on the same location, and it can be analyzed. The platform given by the GIS, right? So this is the combination of remote sensing and GIS. So the multi-concept is different platform, different altitude, different times and dates, different sensors, different spectral bands. Based on that, complementary remote sensing works, and the data obtained from that can be processed and produced report by the GIS. So the remote sensing and GIS are separate, but without their combination, nothing is possible. Right? I hope I have given the introduction about the remote sensing and GIS, friends. Thank you. And this is the last video of the surveying subject. Right? Thank you, friends.